Hey guys, so today we are looking at Algebra 3's extra little lesson over the unit circle. Now, what I'm going to go over today is one giant piece of information that you will need to have memorized. But I'm not just going to say, here it is, memorize it, and be done, right? If you are the type of person who can just be given something and they'll memorize it, and that's that, they don't need any explanations on anything, then you can skip the majority of this lesson. There's still something you need to know. And I'll talk about that. But I am not the type of person who can just memorize stuff willy-nilly, right? Give me a second. I am the type of person who needs some sort of baseline framework to like build my way up to the actual thing that I'm trying to memorize. And that is what I will provide for you today. We are going to figure out what the unit circle is, and then what the different trig functions of the unit circle angles are, like the common angles. And then we're going to connect the ideas of sine and cosine to y and x, and then we're going to find tangent of common angles. So this is the unit circle. Boom, boom, boom. You should have a printed off version of this given to you on the day that you do this lesson. So whatever day that is the day that I will have handed you this thing. This looks like a lot. It tells you an xy, so this is actually on the coordinate plane, where this is the origin. It gives you the xy plot for every point on this circle that has a radius of 1. All right, so this is the reason this is called the unit circle, is because it is a circle with a radius of 1, right? And so from here to here is a length of 1. So all the way around, it's 1 for the radius. So it lists all of these complicated looking xy ordered pairs. We will learn how to find this. Oh, no, look. There's a normal square root of 2, normal square root of 2. All these totally normal square root of 2. So we've got one that was born with a birth defect. Look at that. Oh my goodness. Poor thing. Poor thing. Anyway, so all these complicated looking ordered pairs. We will figure out how to find these, why they're not so random, and this is part of the thing to memorize. Next, they give us the radian measures for every one of these degrees. So pi over 6, pi over 4, pi over 3, super popular angles, 30, 45, 60. And then the actual degree measurements, 30, 45, 60, all the way around. So this would be 30, 45, 60. So hang on, something I want to point out. All right, when you see this, this is 30 degrees, this is 30 degrees. This is 45 degrees. This is 45 degrees. This is 60 degrees. This is 60 degrees. That's a relationship I want you to see. And then down here, we can do the same thing. 30 degrees, 30 degrees. 45 degrees, 45 degrees. And then 60 degrees, 60 degrees. See that? Okay, anyway. These are all related to each other. Anyway, this is the big bad unit circle. We're going to memorize all of it. But we're not going to memorize it all at one time, right? The most I expect you to memorize is this right here. That's what I expect you to memorize. The rest of it you can actually derive from this, and we'll get to that. Now, investigating the xy values of the unit circle. So that's these complicated looking 1/2, square root of 3 over 2, square root of 2 over 2, square root of 2 over 2, that kind of thing. So first, let's look at the 30-degree angle. So here's our 30-degree angle right here, right? I'm going to draw a right triangle like this. So something I want to point out. We know that this is 30 degrees. And we know that this length here is 1. And we know that because the radius of the circle is 1. And this goes from the center to the edge of the circle. we cannot say that this is anything, and we cannot say that this is anything, because this would just be like, we'll call this x and we'll call this y. All right? So we don't know x, we don't know y, because this is at some distance towards 1, and this is, who even knows what this is. But we know this is 1 and this is 30. Right? That's the key. So that's what I put here. Let's look at this 30-degree angle. How can we find x and y? All right, well, that's a interesting question. Here's how we're going to do it. We're going to look at a common 30, 60, 90 triangle. So write down this triangle here, and then, I don't care how much of this you write down, but we're going to look at a common 30, 60, 90 triangle. And for those of you who are all about just memorizing, you need to skip to the part where I get to sine and cosine, okay? That's what you need to skip to. Now, I'm not going to timestamp that for you. So here is a common 30, 60, 90 triangle. If you've got a hypotenuse of 2 on a 30, 60, 90 triangle, like this is a super common one. We've got 1, 2, square root of 3. This is an example of a right triangle with a 30-degree angle where the hypotenuse is in the same location, and the hypotenuse is 2. What we are interested in is an exact triangle, just the same, except the hypotenuse is 1. So these are similar triangles. If you can find, like if the setup is good, which it is here, it's a right triangle, 30 degrees, hypotenuse 2, right triangle, 30 degrees, hypotenuse 1. There's a proportion here. If you take this side length and half it, you get this side length. If you take this side length and half it, you get this side length. And if you take this side length and half it, you get this side length. So what algebraic step could we do to make the hypotenuse 1 instead of 2? Well, you half it. Divide it by 2. So how would that change the rest of the slides? Well, you'd get, here's your 30-degree angle, and here's your right side. You'd get 1 over 2, and then you would get square root of 3 over 2. Sorry for all the scrolling. Now, let's look at sine of 30 and cosine of 30. Excuse me, I have to take a drink. So, sine of 30 and cosine of 30. Last lesson, we should have learned how to take the cosine and sine of an angle. Sine of 30 degrees is opposite over hypotenuse. So opposite is 1/2 over hypotenuse, which is 1. Opposite over hypotenuse. That is, anything divided by 1 is just itself. That is just 1/2, the numerator. All right. Next, let's look at cosine of 30. We've got cosine of 30 is equal to adjacent over hypotenuse, which is square root of 3 over 2 over 1. That's the adjacent, that's the hypotenuse. So this is just square root of 3 over 2. Notice how this, again, is just the numerator. All right. So, all right, we're starting to peel back the inner workings of this math going on here. So let's look at sine and cosine of 30. We did that. Notice how having a hypotenuse, no, remember, you don't have to write this, right? This is just me typing it out. Notice how having a hypotenuse of 1 is very convenient for taking sine and cosine of an angle. Why is that? Well, if you look back up here, cosine and sine both involve the hypotenuse, dividing by the hypotenuse. Dividing by 1 is super easy. That is why it is convenient, because we're dividing by 1, and that doesn't change the numerator. So this is really like sine of an angle. Right? This is the big takeaway. The unit circle will always have this being 1, right? Sine of the angle, whether that be 30 degrees or 45 degrees or 60 degrees or whatever, sine of that angle is always going to be the opposite side, so this side here, divided by 1. So that is just to say, it is just going to be the opposite side. This is huge. Huge, right? So cosine of the angle is always going to be the adjacent side length divided by 1, which is just the adjacent side length. So let's get that straight. In the unit circle, sine of an angle is always going to be if I can spell and write, both of which seem very difficult after an entire weekend of nothing but video games. Sine of theta is always, and I don't type when I play because, a lot of games you do type, but recently I've not been playing any of them they do. Anyway, you don't care about that, and neither do I. All right, so sine of theta in the unit circle is always the opposite side length. Just the opposite side length, because the unit circle always has u divided by 1, which keeps it the same. Whereas cosine of theta is always the adjacent side length. Okay. This is the big takeaway so far, and we're about to make it even like an even bigger eye-opening experience. So in the unit circle, sine of an angle is always just the opposite side, and cosine of an angle is always just the adjacent side. Look how this relates to x and y. So remember, looking back at the unit circle, right? So we got our unit circle here. I told you that at 30 degrees, the x comma y is square root of 3 over 2, 1/2. Remember, take a step away from the geometry here. Just think about the coordinate plane in like algebra, right? The coordinate plane. Here's your origin, right? And so we're putting at this point here. Well, any point on the coordinate plane is written as x comma y, right? Where x is the distance left or right you travel from the origin. So you travel right. That's how far right you go. And then up and y is up how far up and down you go. Are you seeing what I'm seeing? Are you seeing this? The x coordinate right here is just how far left or right you had to go to get in line with this dot. The y coordinate is just how far up and down you have to go to get to the dot. What does that look like? This distance here is just x, and this distance here is just y. Square root of 3 over 2 would be this side length. The 1/2 is right here, right? This 1/2, that 1/2 right there was from this side. The square root of 3 was from this side. All this is about to start coming together. Let's look at the unit circle as it appears on a coordinate plane. All right, so here's the unit circle on a coordinate plane. This is our 30-degree angle. We found this to be square root of 3 over 2. This was 1/2, right? So this dot here is square root of 3 over 2 up 1/2, right? That's the ordered pair. And we can look and it's right on, right? So 1, 2, 3, 4, 5, it's pretty much right on. And what is square root of 3 over 2? Let me get my calculator up. What is square root of 3 over 2? .866. 0.866. Well, if this is 1, right, this is 1, and this is 1, 0.86 would be somewhere around exactly here. So I just want to point out, right, what I'm doing right now is I'm just trying to really cement this idea that this xy is accurate, and it comes from the side length here is the x, the side length here is the y. Okay, so earlier I said that sine of an angle, in the unit circle, is always the opposite side length. But now I'm saying that sine of the angle, or that this length here is, I'm calling y, right? So if sine of an angle is the opposite side, this y here is always also going to be the opposite side. Because think about any angle you draw. Say we draw, this angle here, and it creates this triangle. And we'll talk about this triangle in the future, right? If you're looking at this angle, its opposite side is going to be here as well. Opposite here. Say you create an angle down here, and you've got a triangle here, right? And you're looking at theta. Its opposite side is the y value of this spot here. So what I'm getting at is that sine of the angle is really closely tied to y. And that also means if cosine is the adjacent side is x. When we're talking about these coordinates on the edges of the unit circle. Notice how sine of 30 and cosine of 30 relate to x and y on the unit circle. Well, here's our 30 degrees. Ignore all this extra crap I've written. Sine of the angle is just 1/2, and cosine of the angle is square root of 3/2. Notice how these relate to the x and y on the unit circle. X and y. They're the same. This is the big takeaway. On the unit circle, this unit circle is going to help you so much. Sine of an angle is the y value at that angle's coordinate point. All right, let me repeat that. Sine of the angle is always going to be the y value at the coordinate point for that angle on the unit circle. Cosine is always going to be the x value on that point on the unit circle. So, do I even want to do this? Hang on, let me figure out if I want to do this. Man, the book has, or not the book. I have me doing a bunch of other stuff. When do I get to the point? When do I get to the point? All right, we're gonna skip some stuff because this is just gonna serve to. I might come back to this maybe, but we're gonna get to the point here first. Give me a second. I need to open up another. I need to open up the point of this whole thing. Okay, so the sine of any angle is the y value created at the edge of the circle, which you should have written down. The cosine is the x value created at the point on the circle. So, if I tell you to tell me what is cosine of 60? Well, cosine is the x value, and this is the 60-degree angle. So that's the x value is 1/2, so cosine of 60 is 1/2. This is how powerful this tool is. If I say, find sine of 300 degrees, boom, here's 300 degrees, the y value there, because sine relates to y, negative square root of 3/2. Boom, done. Find the sine of 210 degrees. Well, sine relates to the y value. 210 is right here, the y value is negative 1/2. Boom, done. Find the cosine of 5 pi over 6. Well, 5 pi over 6 is here. The cosine relates to x. Boom, negative square root of 3/2. Done. Another really good thing about the unit circle is that it gives you exacts, right? Like, no approximations. If you tried to do this on your calculator and you did this computation, you'd end up with like decimals for square root of 3/2 and square root of 2/2. You don't have the exacts. And so knowing this is like, it helps you stop approximating. So remember that tangent is just sine over cosine. And if sine is like y and cosine is like x, then tangent is just y over x. So tangent of 30 would just be sine of 30 over cosine of 30, which would be the y value at 30 over the x value at 30. And the same thing is for all these. What? Man, where did the homework go? Oh, I guess you have a worksheet here. All right, so this doesn't have any problems, but here's what I want you to do. All right, I'm going to go over a couple things. I would ask you for stuff like, what is secant of 210 degrees? And you just have to tell me what the secant of 210 degrees is. And here's how you do it. First things first, you would think, okay, secant is the reciprocal of cosine. So the reciprocal of cosine. And then you think cosine relates to x. All right, cosine relates to x. Sine relates to y. So if it's the reciprocal of cosine, that's going to be 1 over cosine. And cosine's like x. So 1 over x. So you're going to look at secant. Actually, you don't even have to think about 1 over. You just think the reciprocal of the cosine, or the reciprocal of the x. So you're looking for 210. Here's 210. Then you're going to look at x, because that's like the cosine, and you're going to flip it. So instead of negative square root of 3 over 2, it's negative 2 over square root of 3. I might ask you for something like, what is sine of 11 pi over 6? Originally, like before this lesson, you'd be like, oh my god, how am I supposed to know? But here, with the power of the unit circle, knowing that sine is like y, here's 11 pi over 6, the y value is negative a half. Done. So I'm going to ask you a whole bunch of stuff like this, and all you need to do is look at the unit circle, and it'll tell you what to do. I mean, it'll tell you the answer. So how about tangent of 7 pi over 4? 7 pi over 4 is down here. Tangent is sine over cosine, so y over x. So that would look like this. Y over x would be the square root of 2 over 2 divided by, actually negative, over square root of 2 over 2. It's the y value over the x value. So that is going to be just negative 1. Check that out. Because anything divided by itself is 1, and there's the negative sign attached. This is how you use the unit circle. So just off the cuff, I'll put my pen down. Just off the cuff, I'm going to tell you to do a couple of things, all right? And then I'll see if you're right, and you can see if you're right. All right, tell me the cosecant of 5 pi over 6. It shouldn't take any effort at all. Just looking at this, you should be able to tell the answer. What is the cosecant of 5 pi over 6? And then let me run through my thought process as I'm doing it. Okay, I see 5 pi over 6. It's right here. So I know I'm messing with these points. Then I was asked for cosecant. Cosecant is the reciprocal of sine. Right? This is like it's like a chain of logic. Cosecant is the reciprocal of sine, and sine is like the y value. And the y value is a half. So then working backwards, if a half is my y value, and then I'm looking for the reciprocal, it's going to be 2. So cosecant of 5 pi over 6 is 2. Done. All right, then you guys try, how about cotangent of pi over 3? That one's a little more difficult. Cotangent, at least in simplified form. What is cotangent of pi over 3? Well, cotangent is the reciprocal of tangent, and tangent is y over x. So cotangent is x over y, and so it would be 1/2 over the square root of 3 over 2, which would be 1 over the square root of 3 when you simplify. Are you guys starting to see this, maybe? If not, you'll have time to ask me questions, and I encourage you to do so. I guess I was going to go through here and do each of these, so let's go ahead and do that. So tangent of 30 would be sine of 30, which is a half, over the cosine of 30, which is square root of 3 over 2. Multiply by the reciprocal. Okay, then tangent of 45 degrees. What I would do on your own unit circle, I would write down on the side like common tangent angles, like I'm doing here. So I would write down tangent of 30 equals 1 over square root of 3. That is also known as the square root of 3 over 3. To the, oh man. Do I even want to get into it? I don't think, I want to keep a positive mental attitude. Let's not even think about all these losers who rationalize the denominator, all right? If you're one of those people, you know, I guess you're just positive, Mr. Dybel. All right. So, tangent of 45 degrees. Well, that's sine of 45, which is the y at 45. So the y at 45 is square root of 2 over 2. And the x is also square root of 2 over 2. So we've got square root of 2 over 2 and square root of 2 over 2, which is 1. Then tangent of 60 degrees is going to be the sine of 60 over the cosine, so this over this. So square root of 3 over 2 over 1 over 2. Square root of 3 over 2 over 1 over 2. Multiply by the reciprocal, and you get square root of 3, another common angle. And then tangent of 90. Ooh, big one here. Here's 90 degrees. Whoop, right there. Y over x. 1 over 0. That is undefined. Big one. All right. You have a worksheet to do. I will have made it and given it to you, or it's available for pickup on like at the table. Work on that. Make sure you ask questions. Your first quiz is coming up very soon. I mean, very soon. So get to it.